Hey everybody, and welcome back to Frontend Expert. In this video, we will be going over browser storage. So we will be looking at different ways that we can store information in the browser and even have that information persist so that, for example, when a user closes the tab and then they come back the next day, we can still have them signed in. If we had a shopping cart, we can still have the shopping cart information in there. They won't have to do everything over again. So that's what we're trying to do. And in this HTML file, there's not too much, it just has an H1 that says browser storage. We will mostly just be interacting with the console in the browser for this video. So let's come over to the JavaScript file. And the first thing I want to talk about is going to be cookies. So cookies are the most traditional form of browser storage, and they're simply key value pairs. These values are all going to be strings. Now, by virtue of being the oldest form of browser storage, cookies also have a little bit more confusing of an API to work with, but everything revolves around the document.cookie value. So for example, we can do console.log, and we can say document.cookie, and I can save this, and you'll see we logged out an empty string, so it looks almost like we didn't log out anything. But document.cookie isn't just any string. Document.cookie is a string that contains all of the different cookies that are set for this page. And those cookies can actually be set by a server. So the server, when it sends the page down to the browser, it can set some cookies with it. Or they can be set by JavaScript like we're going to look at here. But this cookie property of the document isn't able to just be set like any other property. It has a getter and setter function, so it doesn't allow us to completely override it. So when we do want to set a cookie, what we can do is we can say document.cookie, and we will set this equal to a string. So this is calling the setter function of document.cookie. And first we give it a key, so for example, the user, and then we use an equal sign, and we can say, for example, the user is going to be set equal to Connor. And we can save this. And you'll see now when we log out document.cookie, it says user is Connor. And what's interesting about this is if we set another cookie, so for example, I'm going to change this now to be the cookie of course is going to be equal to frontend expert. So when I save this, you'll see that now we have course equals frontend expert as well as the user equals Connor cookie, and they're separated by a semicolon and a space. So what is interesting about this is that even though we set the cookie again, it doesn't delete the previous cookies. They will not be deleted until they expire. So the default is that they will expire when the session ends, meaning when the browser tab is closed, but we can change the expiration to be whatever we want. And we will look at that in a moment. But what I also want to show is that you can override a cookie. So for example, instead of course equals frontend expert, let's update the user once again. So we can say the user is now going to be Clement. We can save this. And now you can see we have courses frontend expert and the user is now Clement, but we no longer have the user equals Connor cookie. Okay, but if this is the case, how do we delete a cookie? Well, there is no delete function or anything like that, but what we can do is set the cookie to be expired immediately, and that will cause the cookie to be deleted. So the way that we can set an expiration is by adding a semicolon at the end of the value, and then after this semicolon, we can add different property value pairs that are essentially like parameters to the setter function of document.cookie. So one of the most important ones here is going to be the expires parameter, and this allows you to set when the cookie expires. So if we want to just delete the cookie, we can say it expires right now or even at a time in the past. So what we want to do is set this equal to a value that is a UTC formatted date string. So I'm actually going to change this string to be a template literal. This is just going to make the string concatenation a little bit easier. And what we want is a date string that is right now. So we can create a date by saying new date, and then we need to convert this to be a UTC string. So we can say .to UTC string, and we can call this function. And now if I save this, you'll see when we log out document.cookie, all we log out is course equals frontend expert because of the fact that the user equals Clement cookie has expired. Now there is one more way that we can delete a cookie. So I'm going to remove the expires portion of this cookie, and let's actually add the cookie back for a moment. So I will save this, and you'll see we have user equals Clement again. And now the alternative way to delete the cookie is we can set what is a max age. So max age works just like expiration, but instead of being a time, it is going to be the number of seconds that we want the cookie to exist for. So I can set this to be a max age of 0, saying we want the cookie to last 0 seconds, which will immediately delete it, and we get the same output. Now, either of these is fine. Setting the expiration tends to be the more traditional approach, but I do think setting max age is actually a little bit cleaner, so I would usually recommend doing it this way. Now, there are a few other parameters that we can use with cookies that can be useful. So for example, instead of this max age, I could set the path, and the path is going to be a path within the website where the cookie is actually used. So not all cookies need to be stored at the top level. So for example, we could do just the root, or we could do the root / maybe my directory, and the cookie would be specific to this path. There are also going to be some security related properties that we can set. So for example, we can set the secure property, and this one doesn't actually take in a value. And all this says is that the cookie should only work over HTTPS. We don't want to send it over HTTP, which is the less secure version of HTTPS. We can also set the same site property and set this to be strict. And same site equals strict essentially says that we don't want this cookie to ever be shared cross-origin. So when I save this, you'll see that we now have user equals Clement back in our document.cookie, but you actually can't see the other properties that we set with that cookie when you log out document.cookie. However, if we come over to the browser, we have this application tab in the inspector, so we can click on the application tab, and you'll see we have this section called storage. And down near the bottom is going to be the cookies section, and you can see we have the domain that we are currently on, and you can see we have the two cookies we have set. So we have the user cookie and the course cookie with the values of Clement and frontend expert. You can also see that we have some other information here. So for example, they both have a path of the root. They also both expire at the end of this session, which is the default case if you don't set an expiration date. And next we have the size, which is simply how large the cookie is, how much space it is taking up. Neither one of them are set to HTTP only. However, the user cookie is set to secure, which is essentially saying we only want to use HTTPS. And then we can also see that the user has a strict same site value. There's also the same party as well as the priority, but neither of those have been changed. Okay, so now one final question you might have about cookies is that if we come back over to the console, you'll see that we have this string that is separated by a semicolon and a space, but how do we even get the values from our cookies? So what we can do is come back over to the JavaScript, and let's try to find a way to get these values. So I will delete this code, and let's try to get the course. So I will say const course, and we can set this equal to document, and I will go to a new line because this line is going to be fairly long. So we can say document.cookie, and now what do we need to do with the cookie? So we have that string that we can see in the console, and it has a delimiter of a semicolon and a space. So what we can do is come to the next line, and let's say .split, and we will split on that delimiter, so the semicolon and the space. Okay, so now we have an array of these key value pairs. But what we want to do is we want to get the course. So we can say .find, which is going to iterate through the array, and it's going to look for the first element that returns true for a callback function. So we can say we have the cookie, and this will be an arrow function. And we want to check if the cookie is going to start with, so cookie is a string, and we want to check if it starts with whatever we are looking for. In this case, we're looking for course, so we want the cookie that starts with course equals. We want to include the equals here to make sure that we don't accidentally get a cookie that was something that started with course but had some other characters after it. So if we see an equal sign, we know that we have reached the end of the name of the cookie. Okay, so now we have the cookie, and we need to get the value. So let's come down to the next line, and we can once again split the string. So we can this time split on the equal sign. So the value on the left of the equal sign is the name of the cookie, and on the right is the actual value. So that means that we just need to get the second value, which is going to be index of 1. Okay, so we can add a semicolon, and let's simply log out course. So we can say console.log of course. We can save this, and you can see we log out frontend expert. Okay, so now with that, that's going to be the end of the section on cookies. One thing I will say about cookies is, as you can see, they are pretty complicated to work with because you have to do so much string manipulation. So most of the time, I will recommend using one of the other options, but cookies can be useful in certain circumstances. There also are some really good libraries out there that you can use for cookies that will do all of this for you, and they create functions such as setCookie, getCookie, etc., so that you don't have to worry about the string manipulation manually. Okay, so I'm going to delete all of this code, and what I want to look at next is something known as the Web Storage API. So the Web Storage API contains two primary types of storage, local storage and session storage. So both of these are essentially the exact same thing. They contain key value pairs just like cookies do. The main difference is going to be that they are much easier to work with. They actually have functions we can use instead of having to use the getter and setters of the document cookie property. We also usually end up getting a little bit more space with local storage and session storage. So if you need more space than cookies can allocate to you, local storage and session storage can be good. And the only difference between local storage and session storage is that local storage does not expire, whereas session storage expires at the end of the session. So there is another caveat there that if you need something to expire at some point in time, then cookies might be better than local storage because we can't set an explicit expiration date. You have to manually delete the local storage value. And finally, the last difference is that cookies are oftentimes set by the server, whereas local storage and session storage are more specific to the browser and our JavaScript. But that's not to say that you couldn't send something from the server, then have JavaScript add it to local storage. Okay, so how do we use local storage? Well, we simply say local storage dot, and we can call the setItem method. And this method takes in the key and the value. So for example, we could have that same user and set it to be Connor. And then we could also maybe set another one. So we could say local storage dot set item, and this one we can set the course to be frontend expert. And then to actually get the items, we can say console.log, and we could do local storage dot get item, and we pass in the key. So for example, get the user key, and we can save this, and you can see we log out Connor. And finally, we can remove items from local storage. So we can say local storage dot remove item, and we pass in the key like this as well. So we can say remove the user, for example. And now if I try to get the user again, so we can say console.log local storage dot get item, and we will get the user item, and we run this code, you will see we log out null because there is no user. You can also call this function that is local storage dot clear, and all this does is it removes everything from local storage. So it clears it completely out. So now not only can we not get the user, we also will not be able to get the course, and it looks like this was spelled wrong up here, but regardless, because we cleared it out, now when I run this, you'll see we still get null because there is no course. And even if we comment out the remove item here and we say log out the user, we added it on this first line, but we will be removing it here, so there is no user. And when we run this, we once again get null. And that is all there is to local storage. It is very simple, as well as session storage works the same way, except instead of local storage, you call session storage. And we can actually see this in the application tab of the Chrome Inspector as well. So I will click on application, and instead of cookies, we can see we have local storage and session storage. So if I open up local storage, we can see the key value pairs that we have here. There are none because we cleared them out. However, if I comment out this code and we run this again, which will set the user and course again, then now you can see in the application tab, we now have the user and the course as keys and the values of Connor and frontend expert. Okay, so now that's going to do it for the web storage API, but the last thing I want to look at is something known as indexed DB. So let's remove all of this code once again, and indexed DB is going to be a more complex storage system. So we don't use it too often, but when you need more complex data than just these key value pairs, we can use indexed DB, but it is going to be a little bit more involved to work with. Specifically, indexed DB is going to be an object store database. So this means that we are storing essentially JavaScript objects, so we can even store entire files. However, this is not a relational database, so it does not use SQL or any other relational database languages. So first, to create a database, what we're going to do is say const request, and we will set this equal to indexeddb.open, and this opens up a database. So this is going to be the same function we call to either open a database or to create a new one. And we give it a name as a string, so I will just call this my database, and then we give it a version number, so this will be version 1. And now everything with IndexedDB is going to be asynchronous, but it works using event listeners. So we can say request.add event listener, and what we want to listen to is this event called upgrade needed, and we can pass in a callback function as well, so we can use an arrow function for this. And this event is going to fire whenever request is creating a new database, or if we have a new version number, so it needs to update the database. Okay, so now first we can get the database by saying const database, and I will set this equal to event.target.result. And then what we need to do is actually create a database object store. So we can say const store is going to be equal to the database dot create object store, and we need to give this a name. So for example, this will be our users. And then we also need to give it this object, and the object is going to have a key path, and this will be set to some value such as ID. So key path is going to set the primary key for the user's store. So every user is going to have an ID, and that will be the primary key for the users. So if you've done database work before, this is probably familiar. If you haven't, this is simply saying that every user will have a unique identifier, and this will be how we reference that individual entry into the user's object store. Now we can also create indexes, so I will add a semicolon here and go to the next line, and we can say store.createIndex. And now an index is going to be a way to quickly search the store for a specific record based on some specific property. So for example, we can call this index name, and we will also give it a key path that is also going to be name. So the first parameter is just a name for the index, and the second parameter determines what object key will be used when we search for a specific record. Okay, so now finally let's add some data. So we can say store.add, And the store.add function is going to take in an object, and this object is going to represent a record that we are adding. So we can give it an ID first, and we will give this one the ID of 0, and then we can give it the name. I will set this one to be Connor. And finally, we will give it the course, and I will set this one to be frontend expert. And we could do this one more time. So let's say store.add. This one will have the ID of 1. It will have the name of Clement, and we can give it the course of Algo Expert. Okay, so now I'm going to save this, and we can come back over to the browser, and under the Storage tab within the Application tab of the Chrome Inspector, we can see a section that is indexed DB. So we can open this up, and we can see the database that we created with the name MyDatabase. We can then open up this database, and we can see that we have our users object store. So when we click on the users object store, you can see we have the object store here with 2 entries. So first of all, we have the entry for Connor with the name of Connor, the ID of 0, and the course of frontend expert. And then we also have the entry with the name of Clement, the course of Algo Expert, and the ID of 1. You can also see we have this key column here, and the key path is set to the ID. So essentially what this is saying is that whenever we search through this object store, we are searching based on the ID, and you can see the ID values here. So we have 0 and 1, which correspond to the IDs that we set. Additionally, within the object store, we can also see our name index. So we can click on this, and we have the same information here. So first here it is showing Clement, and I can click on the value, and we can see we have the same values. So the course of Algo Expert, the ID of 1, and the name of Clement. And you can see that we have the primary key here in the middle. So the Clement primary key is 1, and the Connor primary key is 0. So this is coming from the ID. However, we also have this key over here, which is the key path that we set for this specific index. So in this case, it is the name field. So when we search through this index, we can search based on the name. Okay, so now this upgrade needed event fires the first time that we create a database, or it is going to fire when we upgrade the database. But let's come back over here, and I want to look at what we can do once we just need to connect to a database that already exists. So I'm going to delete this code here, and I'm going to change the event listener to be the success event. So the success event runs whenever we connect to a database. So essentially whenever the open function was successful. And now we still get the database from the event target result, but we can use transactions now to update the database. So the way we can do this is by saying database, and I will go to a new line for spacing, then we can say .transaction. And now the transaction function, first of all, takes in an array with the names of whatever stores we are transacting on. So for example, users. And then it takes in the type of the transaction, which is usually going to be read-write, which will allow us to read and write to the user's store. Okay, so now we need to get the object store. So we can say .object store, and we want to get the user's object store. And now that we have the object store, we can use it basically the same way as before. So for example, we can call the add method. So let's add to the object store. We will give this one an ID of 2. We can say that the name here is going to be Ryan, and we can say the course is going to be ML Expert. Okay, so now I will save this. We can come back to the browser. Let's go back to the user's store, and we need to refresh this so it doesn't automatically update. So we need to refresh it. And now you can see we have added Ryan to the database, but doing this doesn't remove anything else from the database or anything like that. Okay, but then your question might be, how do we delete something from the database? So we can come back over here, and instead of calling the add method, what we're going to call is the delete method, and this takes in the primary key value to be deleted. So for example, I could delete with the ID of 1. We can save this and come back to the browser once again, refresh this, and you can see Clement was deleted because he had the ID of 1. Okay, and now lastly, we need to be able to actually get the values from the database. So the way we can do this is by coming back over here, and we can call the get method, and I will get the ID of 0. However, get is going to be asynchronous, so we need to wait for a success event. So I will save this entire call in a request variable, and we will add an event listener to the success event. So we can say request.addEventListener. This will be success, and then we can pass in the callback function. So this will be the event, and then we can open up the function like normal. And whatever value we got is going to be saved in the event target result. So we can say console.log event.target.result. And for example, we could get the name. So we can say .name. Okay, so let's save this. And in the browser, we can come back to the console. And you can see we logged out Connor because Connor has the ID of 0, which is what we got from the database. Okay, so now finally, we can also use the index that we created to get records out of the database store. So let's come back over here. And instead of simply saying .get of 0, let's do the index of name. So this is the index that we created. And instead of getting 0, we can say get Connor. And maybe in this console log, we actually want to get the course. So I will log out results.course instead. And we can save this, and you can see we get frontend expert. Now it's worth noting that the name is not actually a unique ID in this particular database store that I created. So in the case that there were 2 names of Connor, it is simply going to get the first one. It is not going to return all of them in an array or anything like that. Okay, so with that, that's going to be the end of this video on browser storage. With respect to indexed DB specifically, we usually don't use it unless we absolutely need to, and if you do use it, as well as if you use cookies, I usually recommend using a library that's going to make it easier to work with, but indexed DB isn't quite as complicated to work with as cookies, just because it does have more standard functions instead of just setting a single property. But essentially, whenever you can, I would recommend using local storage and session storage just because it is so much less code. However, of course, these other options are great for their particular use cases. So with that, that will be the end of this video. I hope you enjoyed it, and I hope you learned something new. I'll see you in the next one.